Welcome to Ask and Learn.
Question is an ideal diesel cycle has a maximum cycle temperature of 2000 degrees centigrade. The state of the air at the beginning of the compression is P1 95 kilopascal. P1 is given, that is equals to 95 kilopascal, and temperature T1, that is 15 degrees centigrade. This is also given in the question. The cycle is executed in a four-stroke. Each cylinder Eight-cylinder engine with a cylinder bore of 10 centimeter and a piston stroke of 12 centimeter. The minimum volume enclosed in the cylinder is 5% of the maximum cylinder volume. Determine the power produced by this engine when it is operated at 1600 revolutions per minute. You have to calculate the power. Use constant specific heats at room temperature. So to solve this question, we know that the properties of air are also given in the question, that is Cp is equals to 1.005 kilojoule per kg dot K, and Cv is equals to 0.718 kilojoule per kg dot K, and R is equals to 0.287 kilojoule per kg dot K, and K is equals to 1.4. The diagram between P and V can be drawn as like this. This is 4, 1, 3 and 2. This is the heat input, heat added, and this is the heat rejected, Q out. The specific volume of the air at start of compression is, now we'll start the question, and first we will find the volume specific volume at the start of compression is V1 is equals to R T1 divided by P1, 0.287 into 288 divided by 95, that is equals to 0.8701 meter cube per kg. The total air mass taken by all 8 cylinders when they are charged. Now we will write the total air mass taken by all 8 cylinders when they are charged. Is M is equals to all number of cycles, n number of cycles into del V over V1, which is equals to n cycle into 8 V square S by 4 divided by V1, which is equals to, putting the values, 8, 5, 0.10, 0.12 divided by 4 over V1, that is 0.8701. This is equals to 0.008665 kg. Now the rate at which the air is processed by engine is determined from the rate at which air is processed by the engine is determined from M is equals to Mn divided by n revolutions. This is n revolutions. By putting the values, that is 0.008665, this is M, and the value of n is 1600 divided by 60 revolutions per minute. Now this becomes revolutions per second divided by 2 revolutions per cycle, which is equals to 0.1155 kg per second. Since there are two revolutions per cycle in a four-stroke engine, the compression ratio is the compression ratio is R is equals to 1 by 0.05, which is equals to 20. At the end of compression, the air temperature is T2. That is T2 is equals to T1 R power K minus 1, which is equals to 288 into 20 power 1.4 minus 1, which is equals to 954.6 Kelvin. Now we will apply first law. First law and work integral to the constant pressure heat addition gives Qn, that is heat addition is equals to Cp into T3 minus T2, which is equals to 1.005 into 2273 minus 954.6, that is equals to 1325 kilojoule per kg. The cutoff ratio is now we will calculate the cutoff ratio, that is Rc is equal to V3 divided by V2, which is equals to T3 divided by T2, 2273 divided by 954.6, that is equals to 2.381. Now calculate the thermal efficiency by the relation 1 over 1, 1 minus 1 over R K minus 1 into RC K minus 1 divided by K into RC minus 1, which is equals to 1 minus 1 over 20, 1.4 minus 1, 2.38, 1.4 minus 1 divided by 1.4, 2.381 equals to minus 1, which is equals to 0.6304. The power produced. Now finally we calculate the power produced. The power produced by the engine is then W net is equals to MW net is equals to M thermal efficiency Qin, that is equals to 0.1155 into 0.6304 into 1325, which is equals to 96.5 kilowatt. This is our answer. Thank